Okay, one more dilation formula problem. A and B are the center of dilation. And for the purposes of this problem, I'm going to choose this vertice up top, though it could be anywhere. We could choose right here, we could choose over here, we could even choose the origin, but that's not very interesting. So for the purposes of this problem, I'm choosing this vertice on top, and that vertice, just like in the last video, is located at the point 5, 7. So in our formula here, the A and the B are going to be 5 and 7. So we're just going to plug that in. Let's do the x coordinate first. A is 5. And let's do a scale factor of 3. K equals the scale factor, so K is going to be 3. So for this part of the formula right here, I'm going to say 5 plus 3, and I'm going to open parentheses. This x coordinate, this letter x right here, is the x value of the coordinate that we want to move. So let's take this point down here, this vertice. We want to move that vertice, which is located at 3, 3. So the x coordinate of that vertice is 3. So this x value is going to equal 3, and then I'm going to subtract off the a value, which was 5. And by solving that, I'm going to get the new x coordinate, and we do something very similar for y. The only difference, put a comma in there, the only difference is now we're using the letter b, because we're transforming the y value. So the b part of the center of dilation is 7, so that's 7, plus scale factor is still 3, open parentheses, and we still want to move this point down here. The y coordinate for that point is 3, so this y value is going to be 3 minus b, which was 7. And then all of that is kept together in parentheses. This over here on the left gives you the x coordinate. This on the right gives you the y coordinate. And it is PEMDAS 6th grade math at this point. 3 minus 5 is -2. -2 times 3 is -6. -6 plus 5 is -1 for our x coordinate. Similarly over here, let's do some PEMDAS. 3 minus 7 is -4. Times 3 is -12, plus 7 is -5. So this new point is transformed to -1, -5. And notice how that lines up with the projection line just about perfectly. The only reason it's not completely perfect is human error. That is exactly where it ought to be. And once you do one point, you can even kind of fudge your way to the second point, because you know you're using the projection lines, and because this triangle is nice and easy, nice and isosceles, it's going to be parallel and end up right about here, and you could find the exact location using the formula again on this point, or just by using the projection line and then counting down to the new location.